Welcome to the first video of our AI introductory series. In this video, we are setting up macOS to easily host local AI for a variety of use cases. Apple's unified memory hardware architecture allows the system's memory to be shared, which is especially useful when running powerful open-source models that require large amounts of memory. We will be utilizing an open-source project called Ollama to help us run an OpenAI-compatible HTTP service. This service will be the entry point through which many of our tools interact with the different models we download for various use cases. Let's start by navigating to the Ollama website, where you can download the software, set it up, and get started. Once you've downloaded Ollama, simply unzip the file and drag it into your Applications folder, just like any other macOS app. Keep in mind that when installing software from outside the official App Store, Apple will prompt you to verify that you want to run the application as a security measure. Once Ollama is up and running, we'll navigate to the model list provided on the website. Here, you'll find a list of compatible models that can be easily pulled and run using Ollama. We're starting with a fast, reliable model to get us up and running. As the series unfolds, we'll switch models as needed to suit each use case, ensuring we always have the perfect tool for the job. Once you install Ollama, you'll have access to a powerful CLI utility. We'll use it to download the Llama 3.23 billion parameter model by simply typing Ollama pull Llama 323b. With the model installed, it's time to fire up the Ollama CLI once again. This time, we'll ask the model to crack a joke about terminals. Clearly, this model is lightning fast, effortlessly delivering a witty joke in no time. Next, we're switching to the Ollama HTTP API, which will be our primary method going forward. In this example, we use the same prompt to ask for a joke, but we send the request via curl. It's important to note that we've set the stream parameter to false, ensuring we don't receive a streaming response. Additionally, we've added more detail compared to the CLI approach by defining a message parameter. This parameter is a JSON object that includes both a role and the content of your prompt. The role helps structure the conversation by identifying who is speaking. For example, setting the role to user indicates that the content is a query from the user, while responses from the model might be labeled with a different role, such as assistant. This distinction enables the model to better understand the context and flow of the conversation. Let's shoot over the request and see what happens. In the HTTP response from Ollama, we see that not only did we receive a complete reply, but the response also carries a distinct role. While our request was labeled with the role user, the returned response is marked as coming from the assistant. Additionally, the content field contains our joke. This clear role distinction helps maintain the conversational flow and context. Remember when we set the stream field to false? Without it, the response arrives in small chunks, making it hard to read as a single cohesive output. While this streaming method works well for live chat interfaces, it's not ideal for API requests where you want all the details delivered at once. Thank you for watching the first video of our new AI series. In this session, we set up Ollama on macOS, explored both the CLI and HTTP API, and showed why non-streaming responses can be easier to work with. Stay tuned for more videos where we'll build a ChatGPT clone website with advanced features and configuration options, connect an IDE to our local setup for coding, experiment with various models, including the latest hyped reasoning models, and even set up agents to further enhance our AI capabilities.